Hey everyone, and welcome to my free CCNA Cisco Certified Network Associate course. So today we are going to be talking about basic switch management. Over the past videos we have been configuring our switch little by little. Today we are going to take it a bit further. We are going to see how we can secure the switch CLI, what is the difference between password and the secret, what is the difference between shared passwords and a username specific password. Then we are going to see how we can set up the SSH or the remote login into our switch, and in the end we are going to see how we set up the IP address on the switch, because you know that to access remotely through SSH or through telnet we'll need an IP address on our device. So let's get started. So when we talk about securing the CLI of the switch, we are talking about three aspects. First is that we are securing the access through console. So whenever someone logs in through console, they need to have a password. The second aspect is whenever someone accesses remotely, we need to secure that access. So if whenever someone tries to access it through telnet or through SSH, we need to secure that mode. And in the end, whenever someone tries to access the enable mode, so when they are escalating their privilege from user mode to enable mode, they need to provide a password. So let's see the live thing how we do this in our packet tracer. So this is what the output will be on console when you connect to it. And when you press enter, what you get is a prompt. From this prompt, you say enable and you enter the enable mode. So anyone with physical access to the switch will be able to access the switch, get into enable mode and do whatever changes that they want. And we don't want that to happen. So let's see how we can configure the restriction or the security of this thing. So the first thing is that whenever someone enters console, so line con 0, what we want from them is that they enter a password. So here we'll enter say Cisco and we'll enable the login. Let's save this configuration and let's do one thing and reload the switch. So the switch is now reloaded. So what should happen now is when we press enter, we should be prompted for a password. So we are prompted now for the password. So the password that we are going to use is the same password that we used in the configuration, that was Cisco. And if we enter the correct password, we get logged on to the switch. So let's try one more thing. Let's try to enter the wrong password here and see what happens. So we are again prompted for the password. We are not told that we have entered the wrong password, but we are prompted for another password. So what has happened is we have entered password 3 times incorrectly and again we have been logged out and we need to press enter again. So this time let's enter the correct password and we have logged into the switch. So now if we see our configuration, so show running config, this is also our startup config because we saved it. So let's see show running config. So here we see that line con 0 is now protected with the password Cisco. So now we have a device connected to our PC via console. So every time the PC needs to access the switch prompt, it needs to enter a password which is Cisco. Now here there is a problem. No, not the password, but consider this, that our PC is controlled by not one, not two, but 3 users. And we plan that one of the users, that is user number 3, needs to leave the organization. So what is going to happen now? Are we going to change our password again on the switch? Yes, we will have to, because user number 3 remembers that password. So again we'll go into the console and we're going to set a new password for the device, right? So it was Cisco earlier. Now we'll do something else. Say Cisco 123. Now we have another user leaving the organization, that is user number 2. Again we are in a problem that we need to remove Cisco 123 because they know it, and we need to keep a new password, say not again. And this problem keeps on coming back and again whenever there is a new employment or there is an old person being removed. So a better way to address this issue is that each of the users have their own individual passwords. and not a single shared password. So to set up our users with individual passwords, let's enter the configure mode and let's do this configuration. So we say that we have three users, username with user 1, secret, Cisco, then we have username user 2, and then we have username user 3 using different passwords, say Cisco 123. So now what we have done is we have created three users, user 1, user 2, user 3, each with its own individual password. So let's configure console again, and this time around let's do no password. So we don't want to share a shared password. Now we want individual users to log in with their own usernames and their own password. So let's say login local. So login local means that we want the login to happen from the local database. That is the database that we have just created on the switch. Let's save this configuration and let's try it. So now we are being prompted for a username. So let's enter user 1 and password is Cisco. So there you have it. Now user 1 will access console with their own password, user 2 will access console with their own password, and user 3 with their own password. So now if any of our employees, say user 3, were leaving the organization, so we can have say simply no username user 3. So any configuration that we had done with the username user 3 has gone now. Let's save this configuration again. Let's exit and try to log in with user 3. So user 3, password is Cisco 123, and the password is invalid. Why? Because user 3 is now being removed from the system. And also if you see running configuration, so earlier on what was happening was the password was being stored in clear text format, but now the password is hashed and stored in an encrypted format. Although this encryption is not unbreakable type of an encryption, but it is still an encryption. So it is good to use an encrypted, that is secret, rather than using the password command. You can use password command. If you go into configure terminal, you can use username user 3 with password Cisco. The problem with this will be that when you show running configuration, the password will be stored in a clear text format, and this is not a secure way to save your passwords. So now what you saw was that the login database was stored in the device itself. This is again not a very optimized way of doing things. The database could be saved somewhere on the cloud also. The device could be connected to the cloud via internet, and this can be accessed as and when required on demand. The servers that save these kind of database on the internet are known as either Radius servers or known as TACACS servers. So the communication between the device and these Radius and TACACS servers, which provide a remote authentication and not a localized authentication, happens something like this: that the device sends a message that a username wants to access this resource with this username and password. A challenge is sent, and the Radius and TACACS responds either with auth or no auth. That is, either they'll accept this username and password, or they will not accept it and they'll send a no auth. If an auth is sent, then the device sends them a periodic accounting information. So these types of servers, that is Radius and TACACS, do basically three operations: A, 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 also known as triple A. The first is authentication, that is that users' login credentials are checked here, whether the user's credentials are okay or not. Then comes authorization, which basically means that what resources they are authorized to use. And the last part comes accounting, that is the duration, bandwidth usage, etc. All kind of things comes in accounting. The main point of using Radius and TechAxe as a remote authentication server is to save the administrator from the nightmares of managing users on 20 different devices at a single place. So if you have more than one device or more than 5 devices, say 20 devices in your network, you will not go around managing all the devices. So if a user leaves your organization, then you'll have to go into all the 20 devices and unauthenticate the user or remove their settings from that particular device, so that they don't remotely or connect to that device. So a better way to do is to centralize everything into a single point where you know which users are to be allowed and which users are not to be allowed. So now we have configured our console and we have understood how to configure the users also. So let's also configure our telnet. So we can configure telnet by going into the configuration mode, line VTY015 this time around, not line con, because that line con is for console. So here we are going to be first configuring the transport. So transport, that is whether we want a connection to come input. So input, and what all connections are we going to accept. So we are going to accept all protocols. We are not going to accept any connection. We are going to accept only SSH, or we are going to accept only telnet. So here let's say that we want our input to be telnet. So let's put transport input telnet. Again, we'll have to configure either the password. So in telnet we can have a direct password. We don't need a username per se. So we can have a direct password, and then we can have the same configuration like we did earlier with the console, that we can accept login, or we can do is login local, which is that we will give authorization through username and password credentials that we had just created. So the same username and password credentials will be used for console access and for telnet access. So let's do login local. Let's write this configuration, and now we can access the switch through telnet. So we just now see how to configure telnet. But telnet is not a secured way of communicating. Why? Because in telnet we will be basically communicating in clear text with our remote device. And this is not a safe way. We can be susceptible to man in the middle attack. We can be susceptible to many other types of attacks that bad actors can play, and that will put our infrastructure in jeopardy, because they can get access to our network because of the clear text exchange of the details that is happening between the device and our PC. So that is not a way to communicate. So a better way to communicate is through SSH, where the communication is secured through RSA keys, and only the endpoint partners who have authenticated themselves by way of username and password or a public private key combination can communicate and can understand what is happening and what that gibberish data transfer that is happening actually means. So SSH is the way to go about. Telnet is not used that extensively anymore. It is only way that the device does not have the capability of the SSH that the telnet is used. But in modern devices, all the devices come equipped so that they can handle SSH communication. So telnet is not used that extensively. But for accessing through SSH, we will need to do some more settings in our device. Namely, we are going to have to set up a host name of our device, we have to set up a domain name of our device, and this information is used to generate the RSA key. So this information is needed, but the rest, like login local, remains the same, and we need to define the transport also like we did for telnet. So let's see how we can configure SSH in a device now. Let's switch to our packet tracer. So in a packet tracer, let's enter the configure mode, and here let's first set the host name. We set the host name by using the command hostname and then setting our host name. So let's say our host name is SW1. Now we set up the domain name. We set up the domain name by using the command IP domain -name. Let's set up our domain name as training.com, and now we can generate our RSA key. So crypto key generate RSA. So we are now prompted with the number of bits that we want to use. If we want to use SSH 2.0, then we'll have to use minimum of 768. It's always better to use high bitrate, so 2048. That is the maximum that we can use in packet tracer. We can use that. It takes a bit longer to generate, but in packet tracer it will be done in a very speedy way. But in actual Cisco router it's going to take time, or Cisco switch. So now we are told that the key has been generated, and we are prompted that SSH is enabled. The moment the key was generated, SSH got enabled. So inline VTY 015, our earlier transport was only telnet, so we need to define transport input now. We can set it to all, so we'll accept SSH and we'll accept telnet also. So we'll accept all, and our login was already set to local. Let's reset it, and that's it. So now our device is ready to accept connections through SSH. But wait, our device does not has an IP address. Without an IP address, we'll not be able to communicate to our device. To understand how to set up IP address, let's see one thing first on the whiteboard. So our device is a switch which has multiple physical interfaces on it. So port number 1, 2, 3, 4, 5, and so on. But from the outside host, that is client or PC or whatever it is, it sees a single interface on the switch. That is, the client connects to a single interface only. It has a single MAC address also. This single interface is known as VLAN 1, and it's inside the realm of the switch. This VLAN 1, the virtual interface, resides in front of all the physical interfaces that are on the switch. So when we configure the IP address on the switch, we configure it on VLAN 1, and we don't configure it on individual physical ports, that is port number 1, 2, 3, 4 and 5. We configure a single IP address on the switch on VLAN 1. So let's see how to configure the IP address on the switch. So let's get into configure mode, and let's get into interface VLAN 1. So we are not going to enter the interface fast Ethernet 01, 02, 03. No, we are going to interface VLAN 1. And the first thing that we do is no shutdown. So by default, port is shut down. We'll say no shutdown. And we'll configure the IP address here as IP address. You can put a question mark and see that we can enter the IP address either by DHCP or by configuring a physical IP address. So if we configure IP address DHCP, the switch will try to pick up an IP address from a DHCP server which is on the network, or we can enter an IP address 192.168.0.100, and then again a question mark. We put a subnet 255.255.255.0, and this will configure the IP address on the switch. And we can verify this by doing a show IP interface brief. And we see that VLAN 1 has an IP address of 192.168.0.100. So now we can access our switch remotely via SSH or Telnet. So let's try this. Let's go into PC1. Let's try SSH client, and let's do 192.168.0.100. Username user1, connect. We are prompted for password. Password is Cisco, and we can now access the switch. But here we cannot access the enable mode. Why? Because we had not set any password for the enable mode. So to do this, let's go back into our switch. Let's go back into our configure terminal, and let's set enable secret as say nothing. So the password is nothing here. So let's save this configuration and let's go back into our PC. Let's try enable now. We are prompted for password, so nothing. And now we can enter the enable mode. So now we can configure a switch remotely, that is through PC1. We don't have to use console anymore on the switch itself. So that's it for today. I hope you enjoyed today's video, and now you know how to configure your switch for basic access via console, via remote, and what to use like SSH and what not to use like telnet, and how to secure your command line interface, and how to set up IP address on your device. If you like today's video, please do press the like button. Also, please do subscribe to my channel to get the latest updates. Until we meet the next time, goodbye.